So we're going to be continuing with simplifying rational expressions, but these rational expressions are going to have some funky little thing that you'll notice. What it'll be is that you'll have one expression on top that'll be something like a minus b, and then you'll have the same expression on the bottom but reversed, so something like b minus a. And the question is, can you simplify these? And the answer is yes. So what we're going to be doing, and we're going to practice this skill to make sure you've got it, is that if you write it in the same order. So let's say that the numerator, actually I always like changing my numerator. Let's change my numerator around. So let's make it negative b plus a. So I just used the commutative property and just said, hey, let's write it in a different order. And my denominator is b minus a. If you were to factor out a negative 1 from the numerator, right? So if you took negative b plus a and you factored out a negative 1, you'd be left with negative 1 times positive b minus a. So let's see what that looks like in my fraction. I have negative 1 times b minus a all over b minus a. Now, b minus a divided by b minus a is 1, but I'm left with this negative 1. So the short of the story is that anytime you have these terms but in reverse, so 9 minus x and x minus 9, you can just go like this and say, hey, you know what? It simplifies to negative 1. If you're not okay with that, we're going to practice showing the work. So if you had to factor out a negative 1 from here, so if you have 8 minus x and you want it to be x minus 8, again, the first thing you do is change the order, and then you greatest common factor out a negative, and it changes the signs. So what you'll end up with is 8 minus x is equal to x minus 8, but times negative 1. So pause the video, give these two a try, or just keep following along. So again, this one would be negative x plus 2. Divide both of the terms by negative 1, you'd end up with negative 1 times x minus 2. Same thing here, and maybe, sometimes it helps to show this little step in here too, right? Where greatest common factoring out a negative 1. For this one as well, right, we have 3 minus 5x, which we will write as negative 5x plus 3. So it's throwing me off that those brackets are there. I should just get rid of them. Again, we're going to greatest common factor out a negative 1. So the negative 1 is going to come out front, and I'll be left with positive 5x minus 3. So let's look at this in a practical application. Here's two questions. So if I have a question like 9 minus x over x minus 9, the first thing I can do is take that 9 minus x, write it as negative x plus 9, factor out that negative 1 to be left with x minus 9. So instead of having 9 minus x, I'm going to write negative 1 times x minus 9. In the denominator, I have x minus 9. Now I'm allowed to simplify, but it would simplify to negative 1. Okay? And again, you're totally allowed, if you trust this process, you're totally allowed to just go like this and say negative 1 as an answer. Up to you. Some people just don't. They're like, I just want to show work. I can't just say that it's equal to negative 1. I'm like, cool, there's the work. Up to you if you want to show it or not. What about a question like this? Well, when I look at this one, there's not a 5 minus x and an x minus 5, except that my denominator is a difference of squares. So I'm going to factor this to x minus 5, x plus 5, and then I'm looking at these guys. Okay, again, draw a line, simplify to negative 1, or show the work. 5 minus x would be the same as negative x plus 5. If I greatest common factor out a negative 1, I'm left with negative 1 times x minus 5. And again, you'll notice that I'm showing this work not in the question, right? You don't want to do that and then write it and like have to write the denominator and the numerator. Just do it somewhere over here to prove it to yourself. And then this would look like negative 1 times x minus 5. And in my denominator, I have x minus 5 times x plus 5. And then I can simplify. Boom, boom, gives me 1. But in my numerator, I'm left with negative 1 times 1, which is just negative 1. And then in my denominator, I have this x plus 5. Awesome. So that is the section called factoring out negative 1.